Yeah, good afternoon all. Myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence in SR University. So, today I'm going to explain graphs concept, that is Prim's algorithm and Krushkal's algorithm. One second. Then can algorithms, right? Okay, now these are actually called as a minimum spanning tree. This is for the minimum spanning tree. Before this, we discussed about the what is spanning tree, why we learn the spanning tree. See, now the span one second. Yeah. Yeah. Now, spanning tree concept is we have follow the first one is the graph. So graph is a combination of vertices and edges. It is denoted with G equal to V comma E. V comma E. V is mod V is denote the number of vertices. Mod E is denote the number of vertices and number of edges. So now in spanning tree is follow the it is always acyclic. Second one is the acyclic and second one is the now we cover all vertices, not edges. We should cover the all the vertices. This graph is the acyclic graph, and the number of the third one is the number of edges equal to number of vertices minus one. Okay. Now it is a connected graph. Fourth one is the connected graph. This is called the spanning tree. Okay, first one is the acyclic. Now we should cover all the vertices and number of edges equal to number of vertices minus 1, and the graph is a connected graph. Now we have, for example, this is the graph A, B, C, D is the graph. Now we have to create the spanning graph A. We start with A to B, B to C, C to D. This is a spanning graph. And we start with A to D, and D to B, B to C. This is also spanning graph. And A to C, C to and B, and now B to now C to D. This is also spanning graph. Suppose, for example, I have here he is there. You write the A to so now next we will see this one. Now here, the first one, is it cycle or not? What is cycle? What is a cycle? If source equal to destination, the starting vertex is equal to again ending vertex. Suppose you start with A again. If you have take A like this, then this is called A is the source and destination is also A. No, so this is the acyclic. So here there is no edge here. So this is the acyclic. Now we cover all the vertices or not? Yes, we cover all the vertices. Now how many edges are there? Total how many vertices? Four vertices. So how many edges are there? Now this is 1, 2, 3. 4 minus 1, 3. And connected? Yes, it is absolutely connected graph. So this is called the spanning tree or spanning graph. So now coming to minimum spanning tree. Minimum spanning tree, here we want to take the that is called the weights between one vertex to another vertex. Like that is every edge is a connected with the every vertex is connected with the other vertices with some weight, with some cost. Some that's why it is called sometimes economy tree. So now here, how many types of algorithms are there? Two algorithms. One is the Prim's, another one is the Krishkal's algorithm. Now, first one is the Prim's algorithm. 1 second. First one is the Prim's algorithm. Prim's is a minimal spanning tree algorithm. Is one of the efficient method to find the minimum spanning tree of a graph. A minimum spanning tree is a subgraph that connects all the vertices present in the main graph with the least possible edges and minimum cost. So that is the sum of the weights assigned to each edge. Okay, once again I want to read. Prim's is a minimum spanning tree algorithm. Is one of the efficient method to find the minimum spanning tree of the graph. A minimum spanning tree is a subgraph that connects all the vertices in the present graph with the least possible edges and minimum cost. You observe here, students. So what is the first one? Connected graph. You are connected. Second one, a cyclic graph. Third one, mod E equal to mod V minus 1. Fourth one should cover all vertices. Okay, now the first point, we take the first point. Now here we take connected with the minimum cost. Connected with minimum cost. So the connected all the vertices present in the main graph with the least possible edges and minimum cost. So minimum cost, we have a diagram here. I will explain with the detail. The algorithm similar to any shortest path algorithm. So because this is called the shortest path algorithm, so, okay, begins from a vertex that is set to it as a root and walk through all the vertices in the graph by determining the least cost adjacent edges. So adjacent edges. So now you start with A to B is 6 rupees, you called in rupees. A to F 3 rupees, which is the least cost. So always we choose the least cost A to F. And A to F to E, we have a 10 rupees. And actually here this is not correct because this is the directed graph. So F to A is there, but A to F is not there. So A to C, A to B is only path, only one alternative we have. So we have to move A to B and B to C, and another one is the C to D, C to D. And this is the bidirectional. So there is no possibility to connect with E because 13 we have a, and there is no alternative, and we have 10, so there is no alternative. So now here you observe here, we should cover all the vertices with the cost. So declare an array visited to store the visited vertices and for firstly, and the arbitrary root, say yes to the visited array. That is the first vertex. Like in previous example, A is the first vertex. First we visit the A and check whether the adjacent vertices of the last visited vertex are present in the visited array or not. Okay, better we have to create the adjacency matrix. Okay, whether the first visit the vertex and vertex to the other edges, other vertices. So in these adjacent, which is the least one? So we choose the least one. If the vertices are not in the visited array, compare the cost of the edges and add the least cost edge to the output spanning tree. For example, there is no possibility to connect with other edges, so we have to take the average. The adjacent unvisited vertex with the least cost edge is added into the visited array. and the least cost edge is added to the minimum spanning tree output. And step 2 and 4 are repeated for all the visited vertices in the graph to obtain the full minimum spanning tree output for the given graph. Calculate the cost of the minimum spanning tree obtained. Finally, we have to calculate the cost of the minimum spanning tree. So this is the approach of minimum spanning tree. So now here, first one is we visit the vertices. Yeah, find the minimum spanning tree using the Prim's method, greedy approach for the given for the graph given below with the yes. So now coming to here in this graph, first of all, first I want to explain a small graph. Next I want to explain A, B, C, D, E. 2 rupees, 3 rupees, 4, 5, 1, 6. First S equal to A. So A to C 2 rupees, A to B. We have two connected. A, better you write the A to B 3, A to C 2, A to otherwise B to A also 3, B to D 5, C to D 4, B to E 6, D to E 4. These are the additions. Or you write like that as a matrix like this. A to A no cost. A to B, what is the cost? Already we write it. So లైట్ పెట్టుకొని లోడ్ లోడ్ బట్టి ఆడి చేసుకుంటాం A to B3, A to C2, A B to D5, and C to D4, B to E6, and D to E. Okay, here this is the adjacency matrix. We create the adjacency matrix. So now first we visit the A. So A to C is the least cost. True. And A to C to D 4 rupees and A to B is 3 rupees. So better you choose 3 rupees. And B to D, if you want to visit B to D 5 and B to E 6 and C to D 4 rupees. So better you visit D 4 rupees and D to E 1 rupee. So the cost equal to 2 plus 3 plus 4 plus 1. So yeah, cost equal to 10. This is the simple example for the minimum spanning tree. Okay, next one coming to this example. Okay, now here it is a graph like yes, you start with yes, S2 I can explain. Yes is first visited equal to yes. Now S2 S2B is 8 rupees, S2A is 12 rupees. So first we want to take the S2B. Yeah, now this is the minimum spanning tree already we completed. So coming to step 1, create the visited array to store all the vertices into it. So V is empty now. So arbitrary root is first S to B. So 8, that is next one is the 9. So next one is 11, already we discussed. So now coming to next one is the next one, E to C. We have different edges are there, but E to C 18 and E to D 3. So we can choose E to D only because that is the least cost. E to D 3, and therefore E to D is added to the spanning tree. So V equal to S B A E D. So S is the starting vertex. We visit S to B and B to A and A to E, and next one is the E to D. So next step 5, since D is the least last visited, and check for all the least cost edges that is connected to the vertex D. So D to C 15 and E to D 3. So which is the best? And E to D already covered, and only we should cover remaining vertex, that is C. So there is no alternative, remaining all are greater than 15. So we choose D to C. So the final minimum spanning tree is obtained with the minimum cost 46. This is called the Prim's algorithm. And next, coming to Krushkal's minimum spanning tree algorithm is one of the efficient method and effective method compared to Prim's algorithm. Find the minimum spanning tree of a graph. A minimum spanning tree is a graph that connects to all the vertices present in the main graph with the least possible edges and minimum cost. Some of the weights assigned to a edge. So here the main advantage to use the Krushkal's algorithm. So we choose the minimum cost edge anywhere. So there is no need to follow the adjacent vertices, adjacent edges. So directly we can select any edge from whole graph. So that is the advantage to use the Kruskal algorithm. The algorithm first starts from the forest, which is defined as a subgraph containing only vertices of the main graph of the graph, adding the least cost edges later until the minimum spanning tree is created without forming cycles in the graph. So already we discussed. Now the spanning tree, we should follow 4 conditions. One is connected, another one is acyclic, and third one is the number of edges equal to number of vertices minus 1, and finally we should cover all the vertices. So now cyclic graph is master. So now in this example we have taken one example that is called A, B, C, D, and one more is E. A to B 2 rupees, here 1 rupee, here 6 rupees, 5 rupees, 4 rupees, 3 rupees. So now first you write ascending order. So C to E, C to E is the 1 rupee. So this is the first one. C to E is the first one. And next one is the A to B. This is the second graph. Okay, next one is the B to C, third one. And one more is the B to A to D, 4 rupees. So 1 plus 2 plus 3 plus 4, so final cost is 10. So this is the small example to find the minimum cost of spanning tree. Sort all the all the edges in the graph in ascending order and store it in an array edge. Construct the forest of the graph on the plane with all the vertices in it. Select the least cost edge from the edge array and add it into the forest of the graph. Make the vertices visited by adding them into the visited array. Repeat the step 2 and 3 until all the vertices are visited without having any cycle forming in the graph. So now first one is sort all the vertices. In previous example, we have 1, 2, 3, 4, and 6. So total we have a six edges are five edges are there, five vertices are there, six edges are there. So in these six edges we have to choose the we have to select the minimum cost. So one is the minimum cost. So first C2E is minimum cost edge, that is one. So next construct the forest of the graph on a plane with all the vertices in it. Select the least cost edge from the edge array and add it into the forest of the graph. Make the vertices visited by adding them into the visited array. So next one, repeat the second step. Repeat the second step means what? Which is the next minimum cost edge? A to B is the minimum cost edge. So A to B, we have to select A to B. That is 2. That will be add to the forest. And next, repeat again. Repeat again. Second step and third step. Least cost edge. Which is the least cost edge? And A to B is covered and B to C is the 3 rupees. So we can select the B to B2C. So when all the vertices are visited, the minimum spanning tree is formed. Calculate the minimum cost finally, that is the economy tree cost. So final cost is some 10. Same cost, there is no change in the minimum cost, but the pattern will be different. Okay, now coming to this example, we have some graph. We have a graph. So in this graph, total we have seven vertices are there. So A to B, A to C, A to B, B to C, C to F, C to G, A to G, and G to F, and F to E, E to D, and these are all the edges. So which is the minimum cost hedge in the whole graph? So final, I think now B to C, this is the minimum cost hedge. B to D. So we have to select the B to E first. And next, which is the minimum cost hedge? I think this is the minimum cost hedge. So B to A. And next, which is the minimum cost hedge? Now this is the minimum cost hedge. C to F. And which is the next one is the this is the minimum cost hedge. Next one is the this is the minimum cost hedge. And next one is the this is the minimum cost edge. So finally we can cover all the vertices. So first of all, B2, you write like this, B2D and 5 rupees, B2A 6 rupees, and C2 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 F 9 rupees, and again we have F2E 10 rupees, and next one is the B2C 11 rupees and G2F 15 rupees. Okay, now we should cover all the vertices. As the first step, sort all the edges in the given graph in an ascending order and sort the values in the order. These are the edges, these are the costs. So 5, 6, 9, 10, 11. Okay, 11 and one more is 12. That is enough. We have covered all the vertices. So now construct a forest of the given graph on the single plane. Okay, we have seven vertices. Now these are all the now dummy. From the list of sorted edge cost, select the least cost edge and add it onto the forest in the output graph. Okay, which is the least cost edge here? B to D is the least cost edge. Now, so we construct a B to D is the first edge. Visited array V equal to B to D. And similarly, the next least cost edge B to A that equal to 6. So we add it onto the graph. Okay, minimum cost is 5 plus 6, 11. Now, how many vertices we covered? Three vertices we covered. The next least cost edge is the C to F. Already we discussed C to F is the 9. And add it onto the output graph. But there is no connections, but there is no problem also. C2F is the next edge. So minimum cost is now 5 plus 6 plus 9. So total cost equal to 20. Now visited array V equal to B comma D comma A comma C comma F. Okay. The next edge to be added onto the graph is F2E. F2 equal to 10. F2 equal to 10 means where is the F2E? Here we have a F2A. Minimum cost equal to now 5 plus 6 plus 9 plus 10 equal to 30. Now visited how many vertices here? B to D, B to A, okay, B to D, B to A. So we have right B to B comma D, comma A, comma C, comma F, comma E. Okay, how many vertices we covered? I think we cover six vertices, six vertices. So the next edge from the least cost is B to C. B to C is the 11. Hence we add it to the output graph. Output graph. So minimum cost is 41 from 5 plus 6 plus 9 plus 10 plus 11, 41. Visited arrays are B to B comma D comma A comma C comma F comma E comma yes, that is so we visit six vertices. How many vertices we have? Seven vertices are there. Now we want to visit the another vertex that is called G. Yeah, the last edge from the least cost array to be added in the output graph is F to G 12. So minimum cost equal to 5 plus 6 plus 9 plus 10 plus 11 plus 12. So the value equal to 53. The visited array is also we covered all the vertices. We obtain 53. So now coming to the point, what is minimum spanning tree? Spanning tree is a subgraph of main graph. Now it's cover the connected graph. Yeah, connected graph, and we should cover all the vertices. And next one is the it is a acyclic graph. And next one is the mod v equal to mod e equal to mod v minus 1. Now number of vertices here 1, 2, 3, 4, 5, 6. So number of edges are 7 edges are there. So 7 minus 1, 6. Total we cover all the vertices. It is a connected graph. It is a subgraph of the main graph. Okay, this is about the Krushkal's algorithm. So now Kruskal and Prim's algorithm, the main difference is here the Kruskal Prim's algorithm we can select only adjacent nodes, but here there is no need to select the adjacent nodes. So we can select any node from the graph. So this is the main difference between Kruskal and Prim's algorithm. Okay, now this is about the program. This is about the theory concept. Now we want to move to the practical session. Now practical session, I can explain the program also. One second, I stop the sharing. Yeah, all of you look here now. This is the program for the critical algorithm. Okay, first we have to write the header file dash include stdio.h and lib.h. Define v. V is a number of vertices 4. Define e is the edges 5. Now we create the structure with variables u comma v comma w and compare function for the sorting because we can sort the values from one wherever to one edge to another edge. Now constant void star a void star b. Return struct edge a to w minus right struct edge b to w. So we have to compare every vertex, every edge means one vertex to other vertex. We have some values are there that will be considered next. Find the parent node. First, we find the parent node. In previous example, we take the S is the parent node. So find parent comma int I. While parent I not equal to I, so I equal to parent I value we initialized. And union of the two sets. What is union of the two sets? In previous example, B to A and B to D. That is the two nodes are there. That is connected, but C to F is not connected. That is one subgraph. This is another subgraph. Now we have to Join these two subgraphs by using the x comma y. So now the edges are here. I want to take the adjacency matrix 0 comma 1 10 0 comma 2 6 0 comma 3 5 1 comma 3 15 2 comma 3 4. So now how many vertices are there? We have four vertices are there, that is 0 1 2 3. Four vertices are there. Okay, the result V, parent V, I comma j equal to 0, total equal to initially, the total equal to 0, we have to add the what edges with the graph. Now use the sort for the sorting the all elements. Already we discussed in the Prim's Kruskal algorithm. First we sort the elements. Q sort edges comma E comma size of edges 0 compare. So now I equal to 0, I less than V. I less than V means I less than 4, I plus plus parent of I. First initially we take I value equal to 0, parent of I equal to 0, pick edges, I equal to 0 and I less than E. I less than E means I less than 5 and J less than 3, J I plus plus. So now find parent of edge I comma U and I comma U to V. If no cycle, then we can union the elements. Next one is we have to find the total weights. So result of I comma U, result of I comma V. So total equal to result of I comma W. You can print the total. This is the Kruskal's algorithm. Now we want to take the Prim's algorithm also. Okay, no problem. Next video, we will discuss the Prim's algorithm. This is about the Kruskal algorithm. Thank you. Thank you all. Thank you. Thanks for watching these videos. Thanks for your cooperation. Right, and next video, I will explain the sorting algorithms as well as AVL trees. Thank you. Thank you all.